Plain spotting for real time using Kafka and Apache Druid. People in the room who are more observant might have a couple of questions. One of them being, weren't you here 2 weeks ago talking about roughly the same thing? And the other being, where's Peter? What have you done with Peter? So, first question, slightly different talk this time. There will be a little bit of repetition, but it's differentiated enough, so there'll be some new stuff for you to see. Second question, you'll have to wait to the end to find out where Peter has gone. Right, I should use my clicker. That might be a good start. Cool. So for those who don't already know me, I'm Hugh. I'm a developer advocate at Imply. I'm also a maker and a community organizer outside of work. I run some other events in London, including the AI and Deep Learning for Enterprise Meetup. And if you're interested in that, please do give me a shout. But first things first, let's talk a little bit about Druid. If you were here 2 weeks ago, forgive me because I'm just going to repeat a little bit here, but this will be nice and brief. But if you weren't, Druid is an online analytical processing database, or an OLAP database. That's a database that's used for things like observability, clickstream analysis, and user-facing metrics. When talking about what makes Druid special, we can talk about it in terms of its architecture, its parallelism, and its treatment of data. Its architecture is what allows for on-the-fly scalability and high availability deployments. Druid is a shared nothing microservices architecture, which basically means that each component can be scaled horizontally and vertically, and each component has a completely isolated task that it's responsible for. If you lose one of those components, the database keeps working, you can bring it back up again, and no data is lost because it's all in underlying storage. Its parallelism, which is a product of that architecture, allows for sub-second queries from both real-time data sources like Kafka, which is why I'm here talking to you lovely people, and also the accumulation of historical data up to and exceeding petabyte scale. You can have an enormous amount of data in your Druid cluster, and you can query all of it very, very fast. Druid is also a columnar database, which is how it handles data, and it boasts impressive query performance as a result of the kind of clever indexing and partitioning strategies that you can apply to columnar data. So today, I'm going to dig a bit deeper into the demo I came and gave very briefly 2 weeks ago. So this demo is all about tracking aircraft using open source technology. The team and I at Imply are all running receivers that look a bit like this. It's a Raspberry Pi and an antenna, and we're running some software called Flight Radar 24. What that software allows us to do is to receive ADS-B signals from aircraft. ADS-B stands for Automatic Dependent Surveillance Broadcast, and it's the protocol aircraft use to communicate with other aircraft and with air traffic control. If you've ever tracked someone else's flight, or you've looked at the progress of your own flight, it's likely coming from ADS-B data, although they also do some clever things with satellites now over a different protocol. Now, we can listen in on ADS-B signals because they're not encrypted, they're completely open. You know, you wouldn't want to encrypt data that stops aircraft from colliding midair. And we can use that to build some kind of interesting data sets that we can use to play around with real-time technologies. The most interesting things in that data for us at the moment are things like the position, speed, and altitude of aircraft. So I've been a developer advocate at Imply for 5 months. So Druid is fairly new to me and I'm learning a lot. When I'm learning something new, I like to build things. And it sort of makes more sense to me to go and build something and figure out how something works than it does to sit and get right into the docs. So I decided to build some dashboards with Grafana powered by Druid to explore this data set and learn how Druid works. So in our very simple demo here, we've got a few components. Right over here on the left, as I mentioned before, we have a Raspberry Pi that's running Kafka Cat. Perhaps we should be using some other Kafka producer stuff. I'm very interested in the first talk this evening because of that, because we're then pushing that data that we receive from the antenna directly into Kafka on Confluent Cloud. Using KSQL to do some simple transformations on that data. Basically, we're just converting it from CSV data as it arrives on the Raspberry Pi into a JSON ready for the next step, which is ingestion into Druid. Druid is here providing both our storage and our querying. So all that data is ingested into real-time segments and then into persisted segments that we can then query later on. And the place we're doing that querying from here is Grafana. Building visualizations, accessing that data. You can see an example of that down here, and using Druid to provide sub-second queries so we can have that dashboard update really, really fast. So this is a really common architecture of where Druid is deployed, where we are using Druid as the OLAP database for Apache Kafka. So, aside from being siblings under the Apache Foundation, Kafka and Druid also happen to work together really well. In this demo, I'm going to walk you through how Druid can connect quickly, transform a filter, optimize for OLAP, and keep that data optimized, query on arrival with data from Kafka. Also, I'm going to touch briefly and sort of point you in the direction to look at things like mixing workloads and backfill and update, which will be interesting things if you're consuming from multiple sources or if you're interested in doing things like DR and recovery. In addition to consuming from real-time and from streaming sources, Druid also supports batch ingestion, and you can batch ingest from things like object stores, file systems, even a zip file in GitHub if you really want. Whichever you use, you can query your real-time data and your historical data all in one place with Druid. So on the topic of ingestion, let's talk a little bit about how you actually get data from Kafka into Druid. So I'm going to show you here one of my dashboards. So here I've got a dashboard I've built in Grafana that is getting the flight data from the receivers that the team and I are running. We can see a heat map of the readings from aircraft over the last 24 hours and accumulated into our Kafka topic. So over here on the right, you can see all of the different receivers that are collecting data and the number of unique aircraft that have been tracked in the last 24 hours. That we've got some other data calculated down here. We'll touch more on that in a minute. But we can go in and we can zoom in on the city. So if we zoom in on London, there we go. Always fun zooming on a Mac, right? And we can see the receiver like running in my flat, and you can see all of the areas where aircraft are being tracked. And we can click on in that kind of cloud of points, and we can pick out individual aircraft and their latitude and their longitude. So it's a lot of data, and we can visualize it really quickly. But if we want to get that into Druid from our receivers, it's very simple. So I can jump over to the Druid web console. Sorry, it's probably not super visible on the screen. I'm pushing for a light mode. I might try and get it in as an open source contribution. Setting up a new ingestion job is really easy. We have a wizard up here at the top. You can just go in and plug in your Kafka broker details and start ingesting right away. Once you've done that, you can jump over here and see the supervisor. This is one of the unique components I spoke about earlier that's responsible for looking after your consumers, which are ingesting from each of your Kafka partitions. And we can see those consumers over here under tasks. So we can see them running up here. Some of them are failing. I'm going to look into that in a bit. But you can see how easy it is to ingest data from Kafka into Druid. Once we run that consumer, we right away have segments coming in, and we can start querying them and doing stuff with it. So if I jump back to my slides. Cool. So once I've got that data ingested, I can start querying it and doing stuff with it. But to build that dashboard, I had to do some other stuff with my data to prepare it to start building those dashboards. And the Druid features I used to achieve that were transforming and filtering. So this is what the data looks like as it arrives in the receiver. It's not great. It is very sparse. There is not a lot of useful information in each of these messages. It's very repetitive. So we have a lot of messages that have basically the same information. The only difference is the timestamp. The reason for that is because there are several different types of message in the ASP protocol. I think there are 8, and each one can have different information depending on the sensor in the aircraft that it's coming from. They are also full of lots of irrelevant information. So we have lots and lots. You see all of these commas here. These are all empty columns in the data. Empty columns not providing us with anything useful. And there's also a lot of columns in there which we just don't need for building that dashboard and building those demos. All of this is a problem if you're trying to make a nice heat map in Grafana. Thousands of rows of data without the longitude and latitude data we're using to plot the position of those aircraft are just slowing down our queries, and repeated records slow Grafana down as it plots the same aircraft over and over again on the same point. All of this we need to deal with if we want to build a nice visualization. So I've used 2 different tactics to clean it up. I've reduced the number of readings we get per aircraft by using rollup, essentially a group by at ingestion time that's going to cut down on our number of repetitive rows by chunking it all into granularity by time. So I can take my up to 50 messages from a single aircraft in a second and group all of them together into one record for that second or one record for 15 seconds, whatever best fits my use case. I've also defined the schema explicitly by using a dimension spec to remove those unwanted columns. Druid is by nature kind of schemaless, so you can give it any data with any schema from Kafka, and Druid can adapt to that because where the schema is defined is at the segment level. So if I have 2 days of data with one schema and it changes, when that data goes into the schema for the following days, once it goes into the segment for the following days, if the schema changes, Druid will just change the schema for those segments. And you can still query across all of them without running into issues. So transforms and filters in Druid aren't just limited to cleaning up data. We can also use them to do some interesting stuff. Applying transforms for commonly calculated values can save us a lot of time when running queries because we can pre-calculate these values once instead of every time a user runs a query or a dashboard is updated. So I was thinking a bit about like what transforms can I do on this data? Like what's interesting to look at? So let's have a bit of a think. People often say you're never more than 5 meters away from a rat in London. I'm not sure how true that is. I'm not sure how you would even find that out. Like, is there someone out there figuring out rat density? I don't know. But with this data set, we can very accurately figure out how close the nearest aircraft is. There are tens of thousands of aircraft over London at any given time. When we get, as I mentioned before, lots and lots of readings of the positions of those aircraft. So we don't really want to be calculating the distance, which is, for anyone who knows, the formula for doing a 2D vector comparison on a curved surface is fun. It has sine and cos in there like 12 times. It's crazy. A-level maths, we're coming back for this demo. But we can jump back to the dashboard and we can have a look at, down here, we have the average horizontal distance to aircraft. I've used a transform to generate a calculation of that true horizontal distance. I'm not factoring altitude here, mostly because it's pretty much always 35,000 feet. So these numbers will all be like 35 and then, oh, the actual interesting number. So we can ignore that. But we can see that the average horizontal distance to aircraft is much lower for my receiver, which is in London, in comparison to, say, my colleague Kyle, who's thoughtfully named his receiver Beanhead, down in Cornwall. And we can also see that the shortest distance is also significantly lower. You know, the average plane is 6.7 kilometers away from me, but the one that's nearest to my flat right now is less than 70 meters away because I live under a flight path. So this is a really key type of visualization. And we can jump over to another dashboard quickly.
Have you factored into the equation the planes that are actually on the ground at each time?
Yes. So one field that's included in the data is on ground. Which ADS-B uses so people don't get freaked out when aircraft have like a negative altitude or something like that. If you've ever looked at the 3D view of like an aircraft tracking piece of software, they almost always miss the runway because it's actually really hard to consistently report altitude. That's a whole other tangent. But yeah, we're factoring it in at the moment because there's a nice Boolean field which you can pull out. So if I change this. So this is a really key type of visualization when working with data from Kafka, taking some metric and plotting it over time to find insights, which Druid does a really brilliant job of supporting because time is always the primary partition in Druid. Every segment is stored by time. So if you have a query that factors in time, it's going to save you so much time and improve the performance when you're making those queries, because you're only going to read data from the relevant segments. And then any secondary partitions you have will then add performance on top of that, assuming your data model is all good. One other thing actually, I'm going to come back to that in a second. Okay. So, having fun with slideshows here. Come back to the right image. Cool. So we've looked at how we can get data into Kafka and how we can start doing transforms and finding insights, visualizing it. There are some other issues that I have to deal with, though, to get this dashboard working the way I want it to. One of the other issues I had whilst building this dashboard is the variability of the rate of the incoming data. If we jump back to this dashboard here, we look at some of these ones down the bottom, we can see this curve here of the number of aircraft tracked by hour. So this kind of intuitively makes sense, right? There are more flights during the day and less in the middle of the night. But that presents a problem when it comes to ingesting and storing data. It's going to leave us with like an inefficient data shape. Because Druid's primary partition is by time, if you have an hour of the day where there's nearly no data at all, you end up with a really tiny segment. And if you have an hour of the day where there's a huge amount of data, you might end up with multiple segments for the same hour. To have a really performant Druid cluster or to have a really performant distributed database of any kind, you want to have consistent segment size. And how we achieve that in Druid is with something called compaction. So if I jump over to Druid, it's actually very easy to set up compaction. If I just scroll over. So I'm already running compaction on this cluster, but if I wanted to set it up again, I just go over here and I go to edit compaction configuration. And here we can see what's happening in the background. So compaction is another task that runs on a Druid cluster that will go and, in this instance, find segments that are more than a day old to avoid any collisions with real-time data and effectively re-ingest them using a series of rules to build segments of a more idealized size. In this case, roughly 5 million rows. The reason why you want to do this is because it lets you combine all of your smaller segments into segments which are more appropriately sized, and it lets you break up your very big segments, again, into more consistently sized segments. Smaller segments are going to waste time because when you run a query, you're going to be opening up a bunch of segments, and segments are effectively files at the end of the day. So opening lots of files takes time and slows down your query. Equally, having very large segments means you're going to spend a very long time looking for particular records or columns within that segment. So running this compaction job is going to dramatically increase the performance of our cluster over time. It has been running since this afternoon, so we'll see what it's actually managed to do in that period of time. Not a huge amount. Oh, there we go. Okay. So some of our segments have been compacted right at the end, but because I've protected all of my segments that are younger than a day, and ingestion has been running barely more than a day, compaction has not done an awful lot. But after a day, these segments will start to get combined, and that will help save us time at query time. Looking at the segment view also, we can see our real-time segments at the bottom. So these segments are currently being written by the Kafka consumer and accumulating data. And these segments can be queried live. Oh, that's the wrong part. Right. So query on arrival in Druid is super powerful. We can query data as soon as it arrives from Kafka right away with a sub-second latency. And we can get a view with our flight data effectively from the cockpit. So I'm going to take you now to one final dashboard. When I showed my boss Peter this dashboard this week, he was very excited by it. In a way, I was not quite as excited, but you know, here you go. So what we can see here is the latest reading that we have received from an aircraft that is currently in flight, directly from Kafka, from our receivers. So this one, for example, picked at random, is currently being tracked by Helmar over in Germany, who's my awesome colleague who is a customer support. We can see the squawk, which is the ID that you can use to look it up on flight tracking services, and we can get things like the altitude the plane is currently at, the ground speed, which is like a simplified view of the speed of an aircraft, and we can see the heading. And we can also see it live on GPS. And I can jump through all of the aircraft that are currently being tracked by the system, which is quite a few, and we can see the route that they've taken to get to where they currently are. This is a particularly fun one because you can see that it has initially been tracked way down on the West Coast, and that's because it's moved between two receivers. As the team and I add more receivers to this network and more of our colleagues end up with a Raspberry Pi taped to a wall somewhere, we are able to track aircraft as they move between areas where we have coverage, which is pretty satisfying. So this combination of analytics over a longer period and a true real-time data is the real strength of Druid. You know, we can look at these live data as they come in, and we can also look, as we did earlier, at patterns over time, and we can do all of that in one place. I'll jump back to my presentation. Oh, there we go. So we've been talking a lot about this flight demo, which is fun, but it's a bunch of Raspberry Pi spitting out a bunch of data for kind of demonstrative purposes as opposed to a real world use case. So if we're talking a bit about open source Druid and what it's used for in the real world, we can use Netflix as an example. So Netflix use Druid to power their observability and analysis tooling. So if you look at things like your own watch time, or if you're an analyst at Netflix who's looking at the performance of different shows, or if you are a DevOps engineer at Netflix who's looking at the performance of different streaming services, all of that is powered by open source Apache Druid. In the demo, we have like 6 receivers and like 6 users. Netflix have millions of both. Druid is able to scale to meet that challenge. For Netflix, Druid is providing a kind of one-stop shop where you can, as I mentioned before, query that historical and real-time data without having to maintain multiple tools to do that, and while still having really high performance and really low latency for queries of real-time data, and being able to query that historic data in a cost-effective manner. So, just to recap, you've seen how Druid can connect quickly, transform with filter, optimize for OLAP, say optimize query on arrival for your real-time data as it comes from Kafka. If you're interested in seeing how Druid can support mixed workloads, which is to say, querying both from event streaming against batch data, but also now via our async API, querying across things like Iceberg data lakes in parallel with real-time. You can check out our course on learn.imply.io, more on that in a minute. Likewise, backfill and update, which again is useful for things like DR. You can find out more at learn.imply.io. If you're interested in trying out Apache Druid, you can download it from the project website. There's a really good quick start guide on the docs. If you are looking for a managed service, Imply, my employers, are effectively as Confluent is to Kafka, Imply is to Druid. So we look after it in the enterprise space. So there is a database as a service offering called Polaris, which is effectively an enterprise version of Druid as a service. As I mentioned before, the DevRel team publish online courses at learn.imply.io, and we have courses there covering the basics of Druid, data modeling, and operating Druid, which will give you all the information you need to do for things like pulling metrics out of Druid with Prometheus and doing things like configuring your logging. And finally, there's a really awesome podcast with interviews from all sorts of Druid users from my colleague Rena, which is really great. And finally, for those of you who stuck around and wondering where Peter is, we have Druid Summit coming up on the 22nd of October. Peter is flying out to LA very shortly to go and make sure everything's all set with the venue and to do some organizing. But we're really excited to be hosting an in-person conference in Redwood for Druid users who are open source, and to also bring in a bunch of people to talk about different things in the ecosystem. If you're interested, please do check it out. Tickets are available now. And that is all from me. Are there any questions? Oops.